Hello there, Charger family. This is Mrs. Boyd. Welcome to Mrs. Boyd's Math Room. Today, we're going to be talking about angles of triangles. We've already talked about classifying triangles and what that means. Today, we're going to talk about the angles in triangles. The interior angle sum theorem really simply tells us that when we add up all the angles of a triangle, they have to equal 180. So for this particular triangle right here that we're looking at, measure of angle A is 45. Measure of angle B is 95. And we don't know the measure of angle C, but we know it has to equal 180. So let's combine the angles on the left. That's going to be 140 plus the measure of angle C is 180. You can subtract 140 from each side, and we get the measure of angle C is 40. Just like so. Let's look at the next triangle down. We've got the triangle on the right here. We learned that this is an isosceles triangle where these two sides are the same. These two angles are also the same. So we know that angle is going to be 50. So 50 plus 50 plus, let's call that angle X, is 180. That's 100 plus X is 180. That means X is 80. We also know that this angle has to be 50 because these are vertical angles. And the triangle on the left, we know, we'll call that angle Y. 50 plus 40 plus the measure of angle Y is 180. So that's 90 plus Y is 180, or Y is 90. So order we solve these for. First, we could solve 50 in the same triangle, and then 80 in the same triangle. Then we had 50 in the vertical angle, and then 90. You could have done the triangle on the left first, and then the triangle on the right. It doesn't matter either way. Let's look at the next triangle down, triangle ABC and BCD. We have the measure of angle A and the measure of angle B. Now we need to know C. So we can add up A and B. 51 and 47 is 98. And then do 180 minus 98 to get the measure of angle C. So that's ACB is going to be 82. Now the angle BCD, we know that has to be 180 minus 82 because these are supplementary angles. So angle BCD is going to be 98. That's an awful 8. I'm so sorry. Let me write it here as well. Angle DBC, we've got 180 minus 98 minus 48. And that's going to be 34. And angle ABD is going to be 47 plus 34. That's 81. All right, so we're just using the things that we know about how angles are related to find all of the angles in these triangles. Let's look at this crazy complicated shape down here. We know that B, C, and E are collinear. B, C, and E, okay, are collinear. B, C, and E. And C, E, and G are non-collinear. That means G is down here in another plane. It's hanging down below the triangle, this other plane. So let's find the measures of these angles. We want to know the measure of angle ABC. This one gets a little confusing because you have to remember that we're looking at this triangle, A, B, E triangle, okay? So we have the angles of 50 plus 60, which is 110, and then 180 minus 110 gives us 70. So ABC is 70. I'm going to erase this really, we won't do it. This really wonky triangle we've got here. Leave that 70. Now we want to know angle BCD. Well, we know that if angle DCE is 100, that DCB or BCD has to be 180 minus 100, which is 80. I'm going to skip on over to angle CDE on the left because we know DCE is 100. So we know we're going to have 180 minus 100 minus 60 because CED is 60. So that's 180 minus 160. So that's 20. Now let's come back over to ADC because if CDE is 20, ADC is 180 minus 20 or 160. Let's look at ECF. ECF here, if DCE is 100, ECF is 180 minus 100, which is 80. Those are also vertical angles, so we know that for certain. Angles, oh, I put that in the wrong spot. It's, oh, no, it's in the right spot, so sorry. Let's look at CEF. How about? We've got 180 minus 80 minus 30 in this case. So that's 180 minus 110. That means CEF is 70. Angle BCF. We know it's 100 without trying very hard because it's a vertical angle with DCE. Angle EFG. You know what? Let's go to CBF first. That's going to be 180 minus 100 minus 25. So 180 minus 125 is 55, I believe, for that one right there. So EFG or EFG is going to be, we have to see this right angle marker and know that EFG is going to be 90 minus 25 minus 30. So that means it's going to be 35. So that one is 35. Last but not least, EGF will have 180 minus 110 minus 35. So that angle will also be 35. Whew, it's a lot of triangles and a lot of angles in there. Just take it one angle at a time. Don't get confused. Flip your paper over. We're going to look at the exterior angle theorem. This says that the measure of angle A plus the measure of angle B is equal to the measure of angle BCD. So these are called, for angle A and angle B are called remote interior angles. And when we add those together, angle A and angle B, they're the same as BCD. Okay? We kind of proved it up above, or we kind of saw how it worked. But we know that 45 plus 95 is going to be the measure of angle BCD. That is 140 is the measure of angle BCD. We could do it in 2 steps. Let's just show how this is possible. So to find the measure of angle BCA, we would take 180 minus 45 minus 95. I'm apparently off my space here. Whoop. Minus 95, that's a minus. So the measure of angle BCA would be 40. Then to find the measure of BCD, we would do 180 minus 40, which is 140. So we just kind of took a shortcut from a 2-step solution to a 1-step. That's these theorems just make life easier for us. Let's solve for x in these triangles. These remote interior angles, 4x minus 5 and 3x plus 1, we know that if we add those together, we'll get 132. So we combine like terms, 7x plus 6 is 132. Subtract 6 everywhere, and we get 7x is 130. Oh, I wrote something wrong. Oh, that's minus 5, so sorry. So that's not plus 6. Let's just start this over again. So we'll have 7x minus 4 is 136. Add 4, and 7x is 132. Holy moly, 136. And x is going to equal 19.4 or so. Sorry, that was kind of a roundabout explanation. I hope you understood what I was talking about, though. All right. If we know that the triangle on the right here is an isosceles triangle. That means this, and we know that this angle is 92. We also know if we subtract the measure of this one angle, and this is only works for isosceles triangles, 180 minus 92 is 88. And we know that the 2 angles that make up the base of this isosceles triangle are the same. We can divide that 88 by 2 and get the measure of each angle, or 44. We also know that this angle is 44 because those are vertical angles. We can also say that we know that this angle is 136 because these are supplementary angles. And that one's 136 because of their vertical angles and more supplementary angles. To find this last angle, we need to take 180 minus 44 minus 100. And get 36. Okay. We're just kind of solving triangles as we go here. Let's do this bottom left one. We know that angle H is 30. We know that angle I is 90. So we know that angle HJI is, let's find HJI first. So 180 minus 90 minus 30, that is 60. We know that HJK is 180 minus 60, or 120. We know that KJL is also 60 because it's a vertical angle. And IJL we know is 120 because it's also a vertical angle. We don't talk about it here, but we also know that KLJ is 30. Triangle on the right, last one. Angle MNO. So let's see, MNO is going to be 180 minus 145, or 35. Angle NMO is going to be 180 minus 105 minus 35, or 40. Let's look at angle MOP. It's going to be 180 minus 105 because those are supplementary angles. So that's going to be 75. Since this is an isosceles triangle, we know that angle OPM is also 75. Angle OMP is going to be 180 minus 75 minus 75, which is 30. Angle PMQ, let me write that last one down though. PMQ, well, we know that angle MPQ is going to be 105. And then angle PMQ will be 180 minus 105 minus 60, or 15. So this really is going to test how much you've learned so far about triangles and angles and how things are related to each other. This is really what geometry is all about, seeing how things are related. I hope this makes sense. If you have any questions, you know how to get a hold of me. I hope to see you real soon.